Why, hello, Prealgebra students. This is lesson 30. Aren't you excited to be learning this? Our objective for today is how do you write fractions as repeating decimals? So let's just do a little bit of recall on taking fractions and writing them as decimals. So it says write each as a decimal. So here's some fractions, and we'll work with this on the next page. So just remember, we're going to say this 3 goes on the inside and the 4 goes on the outside, so 3 divided by 4. So let's see if we can solve this here. 4 does not go into 3, so we're going to add a decimal right there. We can add on a 0. Well, 4 does go into 30. It goes into that 7 times, because 7 times 4 is 28. When we subtract, we get 2. 4, of course, isn't going to 2, but if we add on a 0, it does go into 20. It goes into that 5 times. 5 times 4 is 20. My remainder is 0. So 3/4 is equal to 0.75. Okay. Do another one. 7 divided by 10. I'm rewriting it this way. Of course, 10 isn't going to 7. So I'm going to add that decimal. Add a 0. 10 goes into 70. Well, 7 times 10 is 70. My remainder is 0. So then 7/10 is equal to 0.7. Alright, now let's try this next one. It was 2/3. So let's see here. 3 doesn't go into 2, so we'll put a 0 in a decimal place. Add on a 0. 3 goes into 20. Well, not 7 times, that'd be 21. So there must be 6 times. And that's going to give me 18, because 6 times 3 is 18. I subtract, I get 2. Okay, it doesn't go into 2, so let's add on a 0. 20. 3 goes into 20. Well, 6 times. 18. Subtract, I get 2. Add on a 0, it goes into that 6 times. 6 times 3 is 18. Subtract, I get 2. Add on a 0, goes in that 6 times. And I don't know about you, but I think we're starting to see a pattern here. It goes into it 6 times every time. And I keep getting a remainder of 2, and then I add on a 0, and it ends up going into a 6. And then 6, 6, 6, 6, 6, 6, 6, 6, 6. And so this, if I kept going on forever, I could just keep doing this for the rest of my life, and I'd keep getting 6s. But it doesn't sound like a super fun activity to me. So then how do I write this? Because it keeps going on forever. You know, it's like, do I write 0.66666 until I like run out of room on my paper? You know, I was like, or, you know, how do I do that? Do I put like 0.66666 ... just in case it keeps going? Or what do we do? Well, we came up with a cool notation. And any numbers that keep repeating over and over again, to show that it keeps repeating over and over again, we can try it like this. 0.6. Let me put a line over it. The little line over it simply indicates that that part is just going to keep repeating over and over and over and over again on throughout infinity. So if you had something that was like 0.123, 123, 123, 123, etc., 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 on going on forever, then you'd write that as 0.123 with a line over the part that repeats over and over and over again. 1, 2, 3. Also, I guess it's worth noting that sometimes you'll get something that goes like 0.8333333. So it's just the 3's that repeating. So you'd write this like 0.83 and put the line just over the 3, because the 3 is the part that keeps repeating over and over again. Alright, so let's see if we can try this a little bit more. It says express each fraction or mixed number as a decimal number. So same idea as what we just did, except we're going to incorporate this idea of having repeating decimals. So I'm going to say 1 divided by 6. Doesn't go into 6, so we'll add the decimal. 6 goes into 10 one time. Gives me 6. Whenever I subtract, I get 4. It goes into 40 6 times. 6 times 6 is 36. And I get 4. 0. Oh, and I'm noticing now, notice I have a 40 here and a 40 here. So this at this point is going to keep going on forever. 6, 6, 6. So then this is going to be 0.16, and the repeating symbol just goes above the 6. Not over the 1 and the 6, but just the 6. Okay, let's try a similar idea here with part B. This is 2 1/3, so I know my answer is going to be 2 point something, whatever the 1/3 is, right? So just go and take 1/3, find out what that is, a decimal. So it doesn't go in there, so add the decimal, and the 0 goes in that 3 times. When I subtract, I get 1, add the 0, 3, 9. Hopefully at this point you're like, oh, there's the pattern, it's just going to be 3 repeating. So this will be 2.3 repeating. Alright, let's try another one. This one says, arrange in order from least to greatest. So let's just, real quick here. This number is like 0.3, and then everything after that are just zeros, right? We don't necessarily have to write it. There's just a bunch of zeros, right? This number has a repeating symbol on it, so it's going to be 0.3333333, and it keeps going, of course, right? And then this number is just 0.33, and then after that would of course be zeros. So remember, we've worked with ordering these before. You're going to start with the ones that the first number to the right, or really the farthest left number. These are all zeros, so then you can move over. These are all 3s, right? So then we move over, because we're trying to find the least one, the smallest one. So then, oh, here we're starting to get a difference. There's a 0 and these are 3s. So which one of those is the smallest? Well, this one is. So that means my smallest number is going to be 0.3. Okay, so that one's now been used. Now let's keep going. These numbers are the same. So now we'll move to the next number. Oh, and here we have a difference. And which one is smaller, 3 or 0? Well, this one's smaller, so I'm going to go with this one, which is 0.33. And then that means the green one's used, and then it leaves just the blue one, which is 0.3 repeating. Your homework for today is on page 194. You're doing the practice set, all of them from lesson 30 and from 29, and as well as 8 more of your choice. Good luck.